Okay, so today we're going to review chapter 6, which was our chapter on solving systems of linear equations. Now, just to review, there are 3 methods to solving systems. There is the graphing method, the substitution method, and the elimination method. Now, if you have a solution to your system, your solution will be an x and a y. So it'll be an ordered pair with an x value and a y value. And at any point, no matter what method you use, you can always check your solution by just substituting in the values for x and y into both of your equations, making sure that they both work out and are true. So if you're working on a multiple choice assessment or something like that, you could even sometimes just check all the solutions that are provided and see which one works versus actually going through the process of solving. So that might be quicker for you. If you know what you're doing for solving, the solving will probably be quicker, but at least it gives you some options to work with. So the 3 methods are graphing, substitution, and elimination. So first, we're going to go over the graphing method. So basically, when we do graphing, we want to get each of our equations into that y equals mx plus b form and graph it. You don't have to graph it in that way, but that's the most common way that people use to graph a linear equation. So if I have my 6x minus 3y equals negative 15, I want to get my y value by itself. So I'm going to move my 6x over to the other side by doing the inverse operation of subtraction. I now have negative 3y equals negative 6x minus 15. And now I'm going to divide everything by negative 3 because I need to get this y value alone. So that means that I'm going to have negative 6 divided by negative 3, which is positive 2x, and negative 15 divided by negative 3 is positive 5. So this will be the equation I'm going to graph. Then the other equation over here, this 2x plus y equals negative 3, I'm just going to move my 2x to the other side by subtracting it. And I have y equals negative 2x minus 3. So now I want to graph both of these linear equations on my graph. And I want to see if there's a point where they intersect. That would tell me that I have one solution to this system, and that solution would be that point where they intersect. So the first equation here, I'm going to begin at that y-intercept of negative 3. And my slope is negative 2, so I'm going to go down 2 to the right 1. Or if you don't really have enough room to get points, I'm going down 2 to the right 1. We have a few, but you can also do the opposite, which would be up 2 to the left 1. And that will get you points across your entire coordinate plane so that you can get a little bit better picture of what this line's going to look like. All right, so now we're going to graph our second equation over here in the green. Our y-intercept was the b value of 5, so I'm going to plot that point at positive 5, and then my slope is positive 2, so I'm going to go up 1 and over 2, up 1 and over 2, or I could go down 1 to 1 to the left to get some points on the other side of this coordinate plane. Now these two were graphed nicely, and we can clearly see that point of intersection right here. So this means my solution for this particular system would be negative 2 and positive 1. And you'll notice that's where the 2 lines cross. This indicates that I have one solution of negative 2, positive 1. And like I said, you can check this ordered pair into both of those original equations, make sure that they are true statements when you substitute it in for both. But in the essence of time, I'm not going to do that on the video. Okay, so number 2, the first equation is already nicely set up for us here, negative x minus 2. And I'm going to go ahead and work out this second equation here by getting my y by itself. So I'm going to subtract the 2x to the other side. This gives me negative 3y equals negative 2x minus 9. And then we're going to divide everything by that -3, making that equation y equals positive 2/3, because the negatives cancel out, plus 3. All right, so now if I'm going to graph these equations, I'm going to graph the one up top that was already in our slope-intercept form. Our intercept here is -2, so I'm going to begin by plotting a point on my -2 on the y-axis, and my slope was -1. So that would mean I would go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Of course, you can also go up and to the left, up and to the left. So this way you get a lot of nice points across your entire coordinate plane. This helps you theoretically draw your line much straighter. And then hopefully, ideally, you'll be able to see a little bit more clearly where these two lines intersect, if they do intersect. The second equation, my y-intercept is +3, so I begin by plotting a point there on the y-axis. My slope is 2/3, so I'm going to rise 2 and run 3 to the right, up 2 over 3, up 2 over 3, or you could do that down to 3 to the left as if the two negatives were still there. Let me draw our line, and hopefully the two lines cross at a nice, pretty point, which in this case, it appears as if they do. So my solution here would be -3, +1. Always make sure you're going across your x-axis first and then up and down your y to identify the coordinates of that point. Again, you can check your work by plugging those numbers back in. All right, and one more bonus problem here. So the first equation, 3x plus y equals 5. We need to get the y by itself for this one, so I'm going to move my 3x over to the other side by subtracting it. This leaves me with y equals -3x plus 5. My first equation, or my second equation, was already in y equals mx plus b, or slope-intercept form. So now I'm going to go to my -7 on this graph here, because that's my y-intercept on that first equation. And then my slope is +1, so I'm going up 1 and to the right 1 across my coordinate plane. And that would be my line there. Now the other equation that I got y by itself, my y-intercept is +5, and this time my slope is -3, which is really like a -3 over 1. So I'm going to go down 3 to the right 1, down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. And you can see, it's hard to draw straight on the screen here. There's a very squiggly line there. But you can see that they're crossing through right here. And this would be +3, -4. So that would be the solution here. So all three of these systems were solved by graphing, and they were all solved to find one solution. So each one of them had an ordered pair for its solution with an x and a y value. Now the second method that we're going to discuss is the substitution method. So there's 3 general steps to our substitution method. First, get a variable alone. Second, substitute into the other equation that you didn't use yet and solve for whatever variable you have. And then put the answer from step 2 back in to find the other variable. Okay, so the first thing we want to do is get a variable by itself. Now, the easiest way to do this is to choose a variable that does not have a coefficient other than a +1. So if you look in example 3 here, we have four choices, two x's and two y's. Well, the x's both have coefficients. The x on the top equation has a -1 coefficient. The x on the bottom equation has a +2 coefficient. So we don't want to use either of those because it's just more work. But both of those y's just have a plus sign in front of them, which means their coefficient is +1. So we won't have to divide by anything. So it doesn't really matter which one you pick, but you'd want to pick one of those y's. I'm going to choose this one because that equation just looks a little bit simpler to me. So for the first step in this problem, I am going to get this y by itself. And I'm going to do that by bringing my x over to the other side. And now I have y equals x plus 1. So at this point now, I'm going to take this x plus 1, and since I know y equals that, I'm going to plug it into the y in the equation that I did not use yet, and that's step 2. So I'm going to recopy this equation here, the 2x plus y equals -2. But I'm going to replace my y with this x plus 1. So that could be a little confusing at first, but basically, since we know y is equal to x plus 1, I can just replace the y here with what it's equal to. Now I can solve this. There's nothing for me to distribute to these parentheses here, so I don't really need them. And now I'm going to solve for the x by combining my like terms. So 2x plus 1x is 3x. And then I just finished solving for that variable, which happens to be an x here. And I'm going to get x equals -1. All right, so now the third part of this problem, the third step is to take this answer from step 2 and put it into, the easiest option is to put it into your answer from step 1. You could also substitute into one of the original equations if you want to. It's just a little bit harder. So I always just my answer from step 2 into my answer from step 1. So y equals, this is going to be -1 plus 1. And of course, that equals 0. So then technically we have a fourth step, right? And that's to write the solution. So we know that x is -1 and y is 0. So we identify our solution as the ordered pair -1, 0. All right, so let's try it for the next one. Now in this one, there's really only one variable that would be a good one to get by itself. Can you see what it is? That's right. Hopefully you picked this x here in the second equation because clearly there's no coefficient in front of that x. So you won't have to divide by anything, so it's a little bit easier to get it by itself. So in order to get this x by itself, we're going to add 4y to both sides. That's going to give me x equals 4y minus 1. You want to write -1 plus 4y, that's fine too. Okay, so now I'm going to use for step 2 the other equation that I didn't do yet. And I'm going to take this 4y minus 1 and I'm going to put it in for the x. So now I have 2 times parentheses 4y minus 1 plus 2y equals 3, and I can now solve for the variable of y. In this case, I have to distribute because I have a number in front of my parentheses here. That gives me 8y minus 2. Then I have to combine my like terms on the same side of the equal sign. So 8 plus 2 would be 10y. And now I'm going to go ahead and get the y by itself. So I'm going to add the 2 to the other side. 10y equals 5. I'm going to divide by 10. And this time I happen to get a fractional answer, y equals 1/2. So the last thing I'm going to do is take my answer from step 2 and I'm going to plug it into my answer from step 1. And that's going to be my third step. So x equals 4 times y, which happens to be 1/2 minus 1. Well, half of 4 is 2, and 2 minus 1 is 1. So that tells me my solution is 1, 1/2. And again, as I always say, you can check any of these ordered pair solutions by substituting them in, making sure that they work for both equations. All right, we got one more little bonus down here. All right, so of these options, it appears to me that this y would be the only one that would make sense to get by itself because it's the only one that doesn't have a number in front of it. So the coefficient's just a 1. So for my step 1, I'm going to use that first equation, and I'm going to get the y by itself. So we're subtracting the 5x over. I have y equals negative 5x plus 4. All right, so now for step 2, I'm going to use the other equation. And I need to take this negative 5x plus 4, since that's what y equals. I'm going to put that in for my y. So I have 7x plus 5, and in place of my y, I'm substituting what y is equal to, and that's negative 5x plus 4. Now I have to solve. If there's a number in front of your parentheses, you have to distribute that. This is a positive 5 that I'm distributing, so I'm going to get negative 25x plus 20. If it was a negative, make sure you distribute the negative with it. Like terms on the same side equal sign can get combined. So 7 minus 25x is negative 18x. And now I'm going to subtract my 20. Negative 18x equals negative 9. And then I'm going to divide here, and I get x equals positive 1/2. And then just like we did in the last two, we take the answer from step 2, put it into our answer from step 1. And then we can find the y value. So y will equal negative 5 times 1/2 plus 4. So this becomes negative 5/2 plus 4. And that's actually going to equal 3 over 2. Excuse me. All right, and so then our final solution is the point or ordered pair 1/2 and 3 over 2. Or if you wrote 1.5 or 1.5, that's fine as well. All right, so let's go on to our third method here, which is the elimination method. It's also referred to as linear combination because you're combining the two equations to eliminate a variable. So the first one's a nice basic one because when we go to add the two up, we add up our x's, we get 6x. We add up the y's, but they give us 0y, which is perfect because that means that they cancel. And then over here, 16 and 8 equals 24. So now we can easily solve for the x. So we're halfway there. And once you get your first answer, you plug it into either of those original equations. It's your choice. So I usually do whatever one looks easier. So this one down here looks a little smaller to me. So I'm going to just choose that. So 2 times 4 minus 3y equals 8. Now 2 times 4 is 8. I'm going to subtract that from both sides of my equation. Negative 3y equals 0. And then don't think this is no solution because we're just dividing both sides by negative 3. And 0 can be divided by anything, and it just equals 0. So then our solution here, our x and our y ordered pair, is 4, 0. All right, so when we take a look at number 6, these two are not going to cancel if we just go to add them, because 5 and 2 would equal 7, and 3 and negative 4 would be negative 1. So they're not going to cancel. We're going to have to change at least one of the equations, if not both, so that they can cancel. So there's no way for me to multiply 2 by something to get a 5, and there's no way for me to multiply the 3 by something to get a 4. So that means we're going to have to multiply both equations. Now, you have options. You can try to cancel your x's or your y's. So you could try to cancel your y's by multiplying both of these equations so that these will both be 10y and negative 10y. If you do that, though, one of them will have to be a negative, so you're going to have to deal with a sign. But I already see that my x's have opposite signs, so if I pick those to cancel out, I kind of like that a little better because now I don't have to worry about signs. I'm just going to multiply the 3 by a 4 and then negative 4 by a 3, and that's automatically going to give me a 12 and a negative 12. So the first equation, I'm distributing this 4. That's going to give me positive 12x plus 20y equals 24. Then the second equation, I'm distributing a positive 3, which gives me negative 12x, positive 6y, and 15. Now I can add up my two equations. Notice the x's, I have a positive and a negative, they're going to cancel. 20 plus 6 is 26y, 24 and 15 is 39. When I divide the 39 by the 26, unfortunately that does not work out evenly, but I believe that it does reduce to 3 over 2. Or you could have 1.5 if that's easier for you to work with. Now, once you get one of your options or one of your solutions, plug it into either of your originals. It doesn't matter which one you want to do. So whatever one looks easier to you, I'm actually going to choose this one here. So negative 4x plus 2y, which I know is 3 over 2, or if you want to use the 1.5, that's fine, equals 5. Now, 3 over 2 times 2, the 2's will cancel, and I'm just left with 3. And that's why I like to keep it as a fraction. Now I'm subtracting 3. Negative 4x equals 2, dividing by the negative 4, and x will equal negative 1/2 when I simplify that. So my solution here would be negative 1/2 and 3 over 2. If you wrote those as decimals, that's fine. So if you have negative 0.5 and then positive 1.5, that's the same thing. Here we have one more bonus elimination problem here. Okay, now this one, you might notice, is not in standard form. So remember, standard form is ax plus by equals c. In order to use this elimination method, you would have to have both of your equations in standard form lined up and stacked on top of each other. So it appears that this one is in standard form, right? But the first one is not. So this y needs to come onto this side, and this 15 needs to go onto this side in order to make it into standard form. So all you have to remember is if you want to move something to the other side, you can do it. You just have to switch the sign. So the negative 4x is going to stay where it is because it's on the left where I want it. But when I move my 5y over, it's going to have to become a minus 5y. Then the negative 15, when I move that over to the right where I want it, it's going to become a positive 15. The second equation was already in standard form, so I'm just going to recopy it. Okay, so now that's great. We're in standard form. Will any of this cancel? Well, 5 and 2 don't cancel. 2 can't even go into 5 evenly. 4 and 5 don't cancel either, and 4 can't go into 5 evenly. So I need to multiply my rows by something to make the numbers the same. So I can do 5 and 2 to get the y's to cancel, or I can do 5 and 4 to get the x's. Usually if I have an option, I like to pick the smaller option. So to me, multiplying this by 5 and this by 2 will keep my numbers slightly smaller than if I did a 4 and a 5. So now we're distributing. 2 times negative 4 is negative 8x. 2 times negative 5 is negative 10y. And 2 times 15 is 30. The second equation, we're multiplying the 5. So we're going to get 25x plus 10y equals 55. Now I can add these and my y's will cancel because I have a positive and a negative 10y. So negative 8 and 25 is going to give me 17x. 30 and 55 is going to give me 85. And does 85 divide by 17 evenly? I'm pretty sure it does. And it is, I believe it's a 5. Okay, so then we're going to take that. You can plug it into one of your originals all the way over here, or one of the other ones. It doesn't really matter. So I'm going to choose, I'm going to choose this one here. So I have 5 times 5 plus 2y equals 11. We know 5 times 5 is 25, so now I'm going to solve for that y by getting it by itself. So I can move my 25 over to the other side by subtracting it. That gives me a negative 14. And then I'm dividing by 2, and y equals negative 7. So my final answer here would be 5 and negative 7. All right, so hopefully this helps clear up any questions you have on any of the 3 methods, graphing, substitution, or elimination, to solve those systems. Now, on the next page, we're going to go over a couple special scenarios that could happen, or special solutions. And there are also 3 types of those, so make sure you're not getting mixed up with the 3 methods and the 3 types of solutions. So there's 3 types of solutions. The problems we've already done, those 9 different problems we did already, all had one solution. There was an XY ordered pair, and that solution was indicating where those lines would intersect when you graph them, which we saw on the graphing problems. Sometimes there's 2 lines that don't intersect, and those are parallel lines. And so those won't have any solutions. You will just have 0 solutions because the lines will never intersect. And the other possibility is sometimes you have 2 equations that are basically the same line, which means that every single point on each line will be exactly the same because they're really the same line. And the term we use for that is the lines coincide. And we say infinitely many solutions. So those are the 3 scenarios that you could come across. Okay. Now, what method you use to solve these is totally up to you. So, for example, the first one, let's say I'm going to use the graphing method. Okay. If I want to do this by graphing, I would just need to get my equations in y equals mx plus b and look at my slopes and my y-intercepts. Now, because the y's are by themselves here, this one would be y equals negative 2x plus 5, and this one would be y equals negative 2x plus 1. Notice they have the same slope. Parallel lines have the same slope. So if they have the same slope, they're definitely not going to intersect. If they have the same slope and the same y-intercept, well, then we know they're the same line and the lines coincide. These 2 have the same slope but different y-intercepts. So that means that they are parallel lines. And that means that there are 0 solutions. All right, so that's one option. So let's say you were graphing. You don't even actually have to graph it. You just get them into slope-intercept form and compare those equations. But let's just say you're like, that's not going to work for me. I don't know. That's not how I would do it. That confuses me. Well, then we could use one of the other methods, substitution or elimination. So how about for number 2, I'm going to use elimination. Right? And the reason why I would use this one is because if you look, both of those equations are in standard form. Again, you don't have to use the method that I'm using. I'm just telling you why I like it. So for this one here, I want something to cancel, right? We were just doing this on the last page. So if I multiply my first equation by a negative 2, then I will have a positive 4x, which will help me cancel with this negative 4x. I also happen to get a negative 2y, which will cancel with my 2y. And then I also happen to get a negative 6. So when I go to add up my 2 equations, it just so happens that all the things cancel. I end up with a 0 equals a 0. Since that is a true statement, 0 really does equal 0, then I know that these are the same line and it's infinitely many solutions, and we just write IMS, okay? So that's another option for you there. Now, if you had done this one by that method, let's say, and you wanted to cancel, and let's say you did the first one, you just change it to a negative, right? So you had -2, negative y equals -5, and you added them up, you would have ended up with a 0 equals -4, which is not true. 0 does not equal -4, and so then you could have gotten no solution that way. So there's many different options, and you could also use substitution method as well. All right, then the last one down here, this bonus one, we can use any method we want. Let's see, I see there's a +2 here and just an x. So for me, the easiest thing to do is just multiply that second equation by that -2. So now I have -2x +12y equals +12. The first equation, I'm just going to leave it. And now I notice when I add these, my x's cancel. I end up with 15y equals 15. Oops. So then I'm going to divide by 15 and y equals 1. Then plug that back in, whichever equation you want. I'll just go to the first one. So 2x plus 3 times 1 equals 3. Subtract the 3. Now be careful because you subtract the 3, it's a 0. That doesn't mean you're done or anything like that. We still finish it because 0 is a solution, so we get x equals 0. 0 is divisible by 2. So my ordered pair here, there is one solution, 0, 1. So there's one solution here, which means my lines would intersect if I were to graph this. Okay, so then towards the end of the chapter, we had gone over graphing inequalities. So it's the same thing as the graphing method, except there's a little bit extra. You have to decide, are you doing a solid line or a dashed line, depending on if you have those little equal to's underneath your inequality symbols. That's when you do that solid line. If you don't have that, it's just a dashed or dotted line indicating that solutions are not the points on the line. Then you're going to shade up or down your y-axis. If it's y is greater or y is greater than or equal to, you shade up because the greater y values are up. If it's y is less than or y is less than or equal to, you're going to shade down because the lesser y values are lower on the graph or down. All right. Again, you have to get these into slope-intercept form first in order to graph them. Okay, so this first one here, I'm just going to write it over here so I have a little bit more room to work with. I'm moving my 2x to the other side. So it's going to become a -2x plus 4. Okay, now I notice right here from my symbol that this is going to be dotted and y is less than, so I'm going to shade down. Okay. Then on the other one here, I'm going to add the 2x to the other side. I have y is less than or equal to 2x plus 4. And if you look at the symbol for this one, right, this tells me it's going to be a solid line. And I'm going to shade down because its y is less than again. So I already know what shading and things like that I have to do just from looking at that symbol. Okay. So the one here in the green, I'm going to begin at my 4. My slope is -2, so down to right 1, down to right 1, down to right 1, down to right 1, or I can go up and to the left. I'm going to do a dotted or dashed line there. And then for shading, we're going to shade down. So I find my y-intercept and I go down. And then everything else on that side would be filled in like that. Then for the other one, I'm going to go to the 4 as well. Look at that. Happens to be the same y-intercept. Up 2 to the right 1, up 2 to the right 1. Or I can go down and to the left. And this one was a solid line. And I'm going to do my shading down this time because y is less than. So I go to my y-intercept and I'm going to shade down. And then everything else on that side. So we can see that the solutions are all the points in that area. So example of a solution would be the origin. If I want to check my work, I could plug 0, 0 in and make sure it works. I could do 0, 1, 0, 2, 1, 0, any point in that double shaded area. Okay. Okay, so the next example, this first one here, I'm going to write it over here just so I have a little bit more room. 2x plus y is greater than or equal to -4. Move the x to the other side so we can get that y alone. Y is greater than or equal to -2x minus 4. Okay, looking at my symbol here, this tells me that I'm going to do a solid line and y is greater, so I'm going to shade up. Okay, so now I'm going to do the other one. I'm going to move my x over to the other side. -2y is less than -x plus 4. Now be careful here because we have to divide by a -2. And when you divide by a -2, that's actually going to flip the direction of the inequality sign. So notice it was y is less than, now it's y is greater than. Then over here, this is really like a 1/2, but the two negatives will cancel out. And 4 divided by -2 is -2. So that's a little tricky. It's very easy to forget to do that sign flip. This one is going to be a dashed or dotted line because there's no equal to. Actually, there was an equal to. Oh, no, there wasn't. It's on this one. Sorry. And y is greater. So that means we're going to be shading up from the line. All right, so this line first. I'm going to graph this one first. Okay, so -2. I'm going to start there. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And then, of course, we can go down and to the left if we want more. Now, we already said this is going to be a dashed or dotted line. And we're going to be shading up. Okay, now the other one, this equation, -4, and then the slope was -2. So I'm going to begin down here at -4. My slope is -2, so down 2 over 1, down 2 over 1, or up 2 to the left 1. And we know this one was going to be solid, I believe. And the shading for this one, because the symbol was a greater than, we are going to shade up. So you have to find your y-intercept, which is down here in the -4, and go up. And then just finish filling in anything that's on that side of the line. All right, and then the area where they were shaded double, that's your solutions. Any point in here. So it's cool because the origin, whenever the origin's a solution, that's a nice easy one to check, a good checkpoint. But really any point in here would be fine. Okay, number 13. So this one here is already set up for us, right? So we don't have to do too much for that one. We do know that this is going to be a solid line, and we are going to be shading up. And this one here, we have to get the y by itself. So all I gotta do is move my x over. This is a pretty simple one. Y is less than negative x minus 2. And this one, because of the inequality sign, it is going to be a dotted line or dashed, whichever you prefer to say. And then y is less than, so we're going to shade down here. All right, so let's graph this one first since I already have the purple on my hand. All right, so negative 2 is the y-intercept. And then our slope was negative 1, which means we're going to go down 1 to the right 1, down 1 to the right 1, or up and to the left, up to the left. And we said this one was dotted, and we're shading down. Now when we shade down, I find my y-intercept and I go down, and then I just finish filling in anything on that side of that line, that boundary line. Okay, now our other equation was a plus 2 for my y-intercept, and it was a 3 over 2 for slope. So up 3 to the right 2, up 3 to the right 2, or down 3 to the left 2. And this one was a solid line. And we were shading up because its y is greater than. So I find my y-intercept, shade up, and continue to shade everything that's on that side. And then, of course, I can see my solution area is that section over here on the left. So any point in here would be a good checkpoint to use. And that's it. All right, now our last one. Okay, so this equation here, I'm going to get the y by itself by simply bringing my x to the other side. So I have y is less than negative x plus 5. I can see that this is going to be a dotted line, and I'm going to be shading down. That's because of this, y is less than. So when I go to graph it, I go up to 5. My slope is negative 1, so down 1 to the right 1, down 1 to the right 1, or up and to the left. Dotted line, and we said we're going to shade down. Okay, now the other equation is an x equation. So I think we did one of those like probably the first day we did this lesson. But this is a vertical line. It's going to go straight up and down. So you find the one on the x-axis, and we're going to do a solid line here because it has the equal to it, and x is greater than. So instead of going up and down for shading, it's left and right. So where are the x's greater than this line? Over here. So we're going to shade to the right. So that's the only time you think right and left is when you have an x equation. If you have a y equals type equation, then you're always going to be thinking up and down. And this is that's more the solution book. All right, we're almost done. The last thing that we had done in this chapter was a couple word problems. And there's two general types. I mean, there's a few others as well, but the two that we mostly focus on is a choice, where you have a choice to make, or a comparison, which is the first problem. When you're making a choice or a comparison between two people, two companies, two teams, two options, typically your equations are going to be in y equals mx plus b. So you're going to have two equations in this format, okay? And so number 9 is an example of a choice or a comparison problem. So for example, we have the tennis team. They want to purchase t-shirts. They have two options. Company A, which is charging a $20 setup and then $8 per shirt. And then you have company B, which is charging $10 and then $10 per shirt. So one company has a little bit more expensive of a setup fee than the other, but then the other company has a more per shirt, like a higher per shirt price. So what we want to do is find out, well, when are these two going to break even? When would it cost the same? Because the company that has the cheaper setup fee, company B, they're going to be cheaper in the beginning, but only up to a certain point. And then when you order more and more, that $20 setup fee will end up being worth it because the $8 per shirt is going to save you money in the long run. So we want to find out, well, where is that changeover going to happen? So the two equations here for company A, that was the $20 setup fee and $8 per shirt. So whatever the per whatever is, that's the variable. So it's $8 times X. X represents the number of shirts. And then Y will be the total cost. So for $8 a shirt plus that $20 setup fee. Now company B, their total cost will be based off of $10 per shirt. So 10X plus the $10 setup fee. Now, because they're both already set up in y equals mx plus b form, usually substitution or graphing is a better option. If you want to go ahead and do elimination, you can, but you're going to have to rearrange your equations to be in standard form, which is just an extra step. So typically on this problem, I would graph if I had graph paper, but I'm just going to substitute what this y equals to here, y equals 8x plus 20, I'm just going to put it in for my other y. So in essence, I'm just equaling these two equations to each other, which is kind of making sense because I want to find out when are these two companies equal. Now we can just solve it, getting all the x's on one side, the constants on the other side. So I end up with 10 equals 2x, divide by 2, x equals 5 shirts. So how many shirts would have to be purchased for the cost to be equal? 5 shirts. At 5 shirts, they're both going to cost the same. They both cost, well, how do we know what they both cost? You have to plug this into one of those original equations. So let's say I do y equals 10 times 5 plus 10. 50 plus 10 is $60. If I did the other one, 8 times 5 plus 20, 40 plus 20 is 60. So basically what you're finding out is that if you're going to purchase 5 shirts, it doesn't matter which company you go to, they're both going to cost you $60. Okay, so if it said which one offers the better price for 12 shirts, well, anything more than 5 shirts is going to be company A. Because company A, even though they had that $20 setup fee, that $8 per shirt, it's going to save you money in the long run. If you had less than 5 shirts, it would be company B. Okay, our last problem for the review is the other type. And this type of problem I have coined by calling cost and quantity. And these are typically set up in standard form, and elimination is usually a little bit easier of a method. So cost and quantity means you're buying a certain amount of something and you're paying a specific price for that something, right? But you're usually buying two things and you're paying a different price for one item and a different price for the other item. So here we have you pay $105 for 8 tickets to attend a festival. Student tickets are $10 each and adults are $15 each, right? So in this situation, your X and your Y are going to be representing the two groups that are both combining together to get something. So we have students and we have adults. And it doesn't matter which variable you give which one, as long as you know what one you assign to each. So when we do these, we want to have two equations. So first, we might have the quantity equation, and then we'll have our cost equation. Now, of the there's four numbers here. Only one of them doesn't have a dollar sign. That's the quantity. So we know that the students plus the adults equal the total. So X number of students plus Y number of adults equals 8 tickets. Then we basically rewrite that equation, but we assign the values, the money values. So students were $10 each. So that would be 10X. Adults are 15 each, so that would be 15Y, and the total cost for the 8 tickets was 105. And so usually that one is the one with all the dollar signs. Once you do this, very simple. I usually use elimination, but first I'm going to multiply one of my equations. It's always going to be the quantity one because your X and your Y are just a plain old X and Y. And I'm going to multiply that by -10. I could also do -15, but -10 is smaller. So -10x minus 10y equals -80. Now I want to add these up. My x's cancel. -10 and 15 is 5y, and -80 and 105 is 25. And now I can solve here. Y is 5. Now remember, that's the number of adults. So I have 5 adults going. If I know that there's 5 adults, how many students plus 5 adults would equal 8? 3 students. And that's it. Good luck on your test.